Today, we are going to put them all together. Want to go back for a second?
Yeah.
Okay.
No, so for the pi over 4, then is it k pi over 4 and then?
For this one, yes, it would be, no, this, if you look at them, they're all odd numbered pi over 4s, so you could use that. Or if you would say, if I start with the period of sine is k pi, okay? I mean, not the period, if I start with the zeros of sine are k pi. So this is sine of x. Then as soon as I add the 2 inside, and again, we're going to think everything that affects the x values. So as soon as I add the 2 inside, my zeros now become this. And then once I include the shift of pi over 4 to the right, so I still have the 2, but now I'm shifting it pi over 4 to the right, I could say, well, I multiplied my zeros by 1/2, and now I shifted them pi over 4 to the right. This is what I would get. So you can sort of use your transformations to write them out. Generally, these are complicated things to do, and they don't like to ask too many transformations of zeros on your exam. But once you noticed, if you did notice here that this was just odd numbers of pi over 4, you could have written this as 2k plus 1 times pi over 4.
Would you have counted it as correct if you did something like 3 pi over 4 plus pi divided by 2 times?
Yes, yes. And you could use that method as well. Okay.
Which is the most?
They're all somewhat equal. Today we're going to look at, and we're going to give some space at the top of page 531, so you can write this at the top of that page. Special order for y equals a sine and this is true for sine or cos graphs. So we're going to look at what happens when we have all the transformations together. Now in our transformations unit, when we had them all together, we went from left to right, and we took points on our original graph, and we went from left to right, so you would have done A first, then B, all of your stretches and compressions, then C and D, all of your translations after. Because we've been developing and noticing some patterns this morning with the A value being the amplitude, the B value affecting the period, the D value changing your center line, there is a shortcut that we're going to use for graphing sine and cos when we have all of the transformations. Again, if you wanted to go back to taking your 5 points and having them the 5 points and having them do all the transformations, it would work, but it would be a lot of work, and sometimes the numbers, because you're using like pi over 2 and pi, it's not nice to work with. So we're going to look at how do we graph it quickly with these values using some of the patterns that we've noticed. And I have an acronym to hopefully have you remember this shortcut method. This acronym, DABC. So what does DABC stand for? That's the order that we're going to use for the shortcut. The D, which is usually the last thing you would do if you were going from left to right, is going to be the first thing that we do. You are going to draw your center line as the very first thing that you're going to graph. After you've drawn your center line, you're going to use the amplitude, which is your A value, to mark the maximum and the minimum. So you're going to mark your maximum and your minimum on your y-axis. We're going to use the b value to find the period. And you might remember that your period is 2 pi over your b value. That works for sine and cos. Again, for tangent, it was pi over your b value, so this was a formula that we looked at. You're going to use your b value to find your period. And like we've done all the way along, you're going to take that period and divide it into 4 equal sections. The reason it's sort of in 2 words here where we say dab C is because at this point, after we've done these 3 things, the D, the A, and the B value, we've labeled our center line, our max and our min, and drawn our period, we are going to temporarily graph before the translation. And when we temporarily graph it, we're going to graph it with a dotted line. So if you're writing this acronym out like DAB-C, that dash is sort of in there to remind you you're going to temporarily, after you do the dab, you're going to temporarily graph it with a dotted line. And then once you've temporarily graphed it in a dotted line, the last thing you're going to do is with your C value is apply the horizontal translation. So we're going to do an example right now. You can do this example at the bottom of page 531. What does this look like? So here's our example. We're going to graph y equals 3 sine 2 x minus pi over 4 minus 1. And we're going to use DAB-C. So according to DAB-C, the first thing you have to do is draw your center line. That's your D value. Our D value is minus 1. So when we go to draw our axes, at minus 1, if you want to use a red pen with a dotted line, we can label y equals negative 1 as our center line, because that's our D value. After the D value, A value, the amplitude, in this case, can you see that our amplitude is 3? That means that we would go up 3 from our center line and down 3 from our center line. So we can mark 1, 2, 3 that our maximum is going to be at 2, and 1, 2, 3 that our minimum is going to be at negative 4. Our B value tells us our period. So since our B value is 2, that's horizontal compression by a half. Well, that means your period that was normally 2 pi is going to get divided by 2, and our period is going to be pi. So if we mark one period pi and divide it into 4 equal sections, half would be pi over 2, half of that would be pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. Now that we've completed the dab part, we can draw the graph with a dotted line. This is a sine graph. Where does sine normally start? Starts in the center line. Goes, and this is where the 4 sections help us out. Section 1, it's going to go up to a max. Section 2, back to the center line. You're going to be tempted to draw it on the x-axis. Make sure you draw that point. It's back to the center line. The 3rd section down to your minimum, and then back to your center line. So temporarily, this is what the graph looks like before we do the shift. This is just the dab. And now we need to shift it pi over 4 to the right. So we take each of the points that we had and move them pi over 4 to the right. In this case, it's nice because pi over 4 is already labeled on my graph. So life is pretty easy. You don't have to make any new labels. But pi over 4 to the right, there's a point. There's a point. There's a point. Pi over 4 to the right. And if we made another one here. And now we can draw our final graph. Put arrowheads on the end to show that it continues. And this is the graph of y equals 3 sine 2x minus pi over 4 minus 1. The old method, you would have to take your original sine function with these 5 points and do all of those transformations to each of the 5 points. And there's just so many opportunities to make mental math errors that it ends up not being nice, and it takes longer. So this DAB-C technique is really helpful because it gets your center line right away. It gets your maximum and minimum from your amplitude. Your period is labeled correctly. And then you temporarily draw it. After that, the shift of that temporary graph is really easy to do. And you have your final graph. Yes? Any math games for this one? No, not off the top of my head. Okay, well, let's do one more example before we get to the examples in our notes. So, graph y equals -2 cos Whew. So first of all, when I'm going to graph this, I'm already thinking about, in particular, my D and my A values of where my graph is going to be. Can you see that your D value is 5? That means your center line is going to be moved up. And your amplitude is 2. Even though there's a negative there, the amplitude is always a positive number. It's going to be 2. So I'm thinking about my range. So I'm not just going to draw my axes like this, because I don't need any of this negative space. So because I'm thinking about it a little bit already, I'm sort of going to draw my axes like this because my center line is right here at 5. My amplitude being 2 means my maximum is going to be at 7 and my minimum is going to be at 3. What's my period going to be?
2.
So our period is 2 pi over your b value, and sure enough, the pi's cancel out, so you get 2. And the first time you see one like this, you feel like, something's wrong because there's no pi's on my axis anymore. That's okay. It's not 2 pi, it's just 2. Divide it into 4 equal sections. What's half of 2? 1. What's half of 1? 0.5. 1.5. Good. We've done the DAB. We've done our D value, our amplitude for a max and min, our B value for a period. Now we temporarily graph it. In this case, normally you say, well, where does cos start? Cos starts at a maximum, but this one is a negative cos, so it starts at a minimum. So we start at our minimum, which is 3. Then go to our middle value. Then our maximum. Back to our middle. Back to our min. Draw it with a dotted line. This is our temporary graph before the shift. And now we need to shift it 0.25 to the left. Now, each of these marks along here have been 0.5. Can you see that negative 0.25 would be half of that? So we need to move this point over half, this one over halfway, this one, halfway, this one, halfway. And there's our final graph. When these questions appear on the final exam, they are almost always worth 4 marks because there's 4 things that they check. Is your amplitude correct? Is your period correct? Is your shape of your graph correct? And is your translation correct? Or the shape of your graph and the center line. So they're basically 1 mark for each of those things, the D, the A, the B, and the C value. So here is example 1. Predict how the graph is related. Well, we've already seen what we need to do for this. We're going to sketch the graph. The hard part here for us is they have given us a domain. So that's going to make our life a little bit more difficult because usually up till now we've just been drawing one period. We're going to look at how we can deal with the fact that a specific domain is given. So, DAB C, a little bit of thinking. Can you see that your center line is up 2? And your amplitude is 1/4. So when I go to draw my axes, my center line is at 2. Again. So I've done the D value. Your amplitude is 1/4. So that means that you're going to go up to 2.25 and down to 1.75. It's going to be a very skinny sinusoidal graph. Our period is, well, that 3 in there is a horizontal compression by 1/3. So our period is going to be 2 pi over 3. Now the question is going to ask us to graph between negative 2 pi and 2 pi. So as a starting point, I'm going to put negative 2 pi over here because eventually this is how much I want to graph. From negative 2 pi to 2 pi. Where does one period of 2 pi over 3 fit on this? 1/3 of the way to 2 pi. So if I break this up into thirds, that's 2 pi over 3. If I break this side up into thirds as well, ooh, those are smaller thirds than the other side. This will be negative 2 pi over 3. Now if we take one period, which is the 2 pi over 3, and we split it into 4 equal sections, this will be pi over 3, pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. Here we have pi over 2. So now we've done the DAB part. We use the D value to get our center line, the amplitude to find our max and our min, and the B value to find our period, and we split our period into 4 equal sections. The hard part in this one, because our final domain needs to be between negative 2 pi and 2 pi, I labeled 2 pi and negative 2 pi on my axes, and then I had to figure out where is 2 pi over 3. How does that work? And so I figured out that that was 1/3, which makes sense since this is a horizontal compression by a factor of 1/3. Now we temporarily draw it. It's a coast graph. Where does a coast graph start? At a maximum. So we start at our maximum. Then go to our middle, then our min, then our middle, then our maximum. And I'll just draw that in a dotted line. Okay? If we wanted to have our graph all the way from 0 to 2 pi, can you see that you would need to divide this section into 4 equal parts until you got to 4 pi over 3. Then this section into 4 equal parts. This section into 4 equal parts, this section into 4 equal parts, and this one. And our temporary graph could keep going. Middle, min, max. Middle, min, middle, max. It's a lot of dots that we have to do here. Middle, min, middle, max. Middle, min, middle, max. Middle, min, middle, max. Woo. So this would be our temporary graph all the way from 0 to 2 pi. Finally, what we need to do is move everything. So the C part is the horizontal shift. Everything is going to get shifted pi over 6 to the left, because it's a plus pi over 6. Now luckily, pi over 6 is one full ticky mark on our axes. So when we move things over, we can just move everything over one ticky mark. Pi over 6 to the left. And then we have our complete graph between negative 2 pi and 2 pi. Again, what would normally happen on this question is you would just have your original green one would have these points. You would shift those points. And a normal equation would just get you to graph one period like that and put arrowheads on the end to say that it keeps going. And life is a little bit easier. This one gave us a specific domain. I think they wanted you to see that compression happening, that you have so many more curves. Oh, some of my minimums do not match up. This is terrible, eh? Come on. Anyways, so I would probably lose a half a mark for accuracy on this one because my minimums went a little bit low. Because 1.7 is 5 is right here. It was like, look at that. Oh, that's good. Not happy. Not happy at all. But I'm not going to redo it right now. Okay. So I want you to practice some of these. So here are some for you to practice. 3, 8, 9, 10, 11. And before you start any of them, I want you to look at number 11 and tell me why the person next to you is going to graph it wrong. Not why you would graph it wrong. Why the person next to you is going to make a mistake in number 11. What are they going to forget? They're going to forget to factor because it's not in factored form. Excellent.